Objective of today class is nothing but dynamically induced EMF. Dynamically induced EMF. In previous topic, we have to discuss about problems on induced EMF, and problems on Faraday's laws of Faraday's second laws of electromagnetic induction. And today, main objective nothing but on the completion of this period, you would be able to solve the problem on dynamically induced EMF, and dynamically induced EMF problems and the derivation for the dynamically induced EMF. So here, before going to dynamically induced EMF, here two types of induced EMF is there. Types of induced EMF and expression of dynamically induced EMF and statically induced EMF. The types of induced EMF. Here the two types of induced EMF is there. Dynamically induced EMF and statically induced EMF. What is the dynamically induced EMF? What is the statically induced EMF? So induced EMF. What is the induced EMF first? What is the induced EMF? When the flux is linking, in a coil or conductor, the move and induced EMF is induced in it. The EMF is induced in that coil or conductor. That means a conductor or coil are placed in the magnetic field, or move or the placing. Then the EMF is produced. In that conductor. The EMF is induced in that conductor. Okay now. So here the flux will be linking. When the flux will be linking, every conductor, a conducting material, are placed in the magnetic field. So the magnetic lines of force, that is the flux. The flux will be linking. In that coil or conductor. Then the EMF is induced in that conductor. So that is called as induced EMF. Change in the flux linkages can be brought about in two ways. So this flux changing. So if the conductor or coil are placed in the magnetic field, the flux will be linking. So we have to change the flux linkages. So the changing flux linkages can be brought about two ways. So first one nothing but a conductor is moved in stationary magnetic field, and second one is nothing but the conductor is stationary, the magnetic field is moved. That means, so what are the meaning of these 2 points? Nothing but a conductor is moved in stationary magnetic field, where the magnetic field is the stationary, but the conductor are the moving. Then the EMF is produced. So here the changing of flux linkages, or EMF is produced in the flux linkages will be changes. The EMF is induced. So here the two ways is there to produce the induced EMF. One way is nothing but the conductor are move in stationary magnetic field, and the conductor is stationary and magnetic field is moving. So here, so there are two ways is there. So the changing of flux is the two ways is there. So that is nothing but here the changing flux linkages. Here the two ways is there, that is the changing conductor are the move in the stationary magnetic field, and the conductor is stationary and magnetic field is the moving. The magnetic field is the moving. Next, the types of induced EMF. Depending on the way in which the change in flux linkages, that depending on the way in which the change in the flux linkages is brought about, the EMF can be divided into two types. The first type is nothing but dynamically induced EMF. Second type is nothing but statically induced EMF. So here the depend upon the way the change in the flux linkages. Here the two types of way to change the flux linkages already we have to discuss just now. So that is nothing but the conductor is move in stationary magnetic field, and another way is nothing but the conductor is stationary, the field is moving. Then the EMF is produced in conductor. So here depend upon the way. So depend upon the way of this changing the flux linkages. The two types of induced EMF. So that is the first type is nothing but dynamically induced EMF. Second one is nothing but statically induced EMF. So what is the dynamically induced EMF? What is the statically induced EMF? We have to discuss now. So dynamically induced EMF. So this is the figure, they are shown in figure. This is the diagram for dynamically induced EMF. A conductor are move through stationary magnetic field of DC generators. So this is the first figure is nothing but DC generators. Second figure is nothing but in this figure AC generators. In the DC generators, the conductor are the move through the stationary magnetic field. Here magnetic field is there, N and S pole. Okay, N and S pole is the magnetic field, and here the conductor are placed in magnetic field. Conductor are placed in the magnetic field. Then a stationary magnetic field. Next one nothing but a conductor are stationary and the field is the moving. In AC generators. So here the AC generator. Here the second figure is nothing but AC generators. Okay na. So this is the DC generator, this is the AC generators. In the DC generators, the conductor are the moving. In AC generators, the field are the moving. The conductor is the stationary. So here, so the dynamically induced EMF, okay now, based on the principle of dynamically induced EMF in AC generator and DC generators, the working principle of DC and AC generators. DC and AC generator is nothing but based on the principle of dynamically induced EMF. So this is the derivation. Of dynamically induced EMF. So you have to observe this figure. You have to observe this figure. So this is the field is there, and that is the conductors. So this is the conductor and this is the field. This is the conductor and this is the field. So here the conductor cutting the rods. The conductor cutting the rods. So here the class where the B is the flux density, where B is the magnetic flux density. In the magnetic field, the conductors are the moving. In the magnetic field, the conductors are the moving. The conductors are moving. The conductors are moving in perpendicular to the magnetic field. In perpendicular to the magnetic field, then the EMF is causes. The EMF is causes in the conductor or coil. In the conductor or coil. If the conductors are the moving parallel to the magnetic lines of force. Magnetic lines of force are magnetic flux. Then there is no EMF is produced in conductor or coil. If the conductors are take some right angle or some angle to the magnetic field or magnetic lines of force. Magnetic lines of force or magnetic field. Then the EMF is produced in that conductor. The EMF is produced in that conductor. If the magnetic field, if the conductors are parallel to the magnetic lines of force, then there is no EMF. So here, where L is the length of the conductor in meter, the B is the uniform magnetic flux density in Weber per square meters, and V is the velocity. V is the velocity of the conductor. Our conductors are the moving in the magnetic field. That is the V is the velocity of the conductor. So here, suppose a conductor move through a small distance of dx in dt second. In dt seconds, the conductor will be moving at a distance of dx in magnetic field. Then the area is swept. Swept by the conductor L into dx, where L is the length of the conductor and dx is the distance is small distance, the moving of conductor. Then the flux will be produced. The change in the flux or flux will be produced in that conductor is equal to flux density into the area shift. The area shift by the conductor or coil. So here the change in flux is equal to the B into L into dx. Where B is the magnetic flux density, L is the length of the conductor, and D is the distance, small distance of conductor moving in magnetic field. So here the change in flux is equal to B into L into dx Weber. According to Faraday's laws of electromagnetic induction, the the EMF is equal to, the EMF E is equal to N into d pi by dt, N into d pi by dt. For single conductor, N equal to 1. So the induced EMF B is equal to B into L into dx by dt, dx by dt. Then the final expression is nothing but the E is equal to B into L into V volts, where V equal to dx by dt, dx by dt. That means the voltage V, the EMF is produced in the conductor, the moving of conductor in the magnetic field, then the small distance the conductor are the moving, that is the dx moment, and in some time period, that is the change in time period, change in the time. So here V equal to dx by dt, V equal to dx by dt. Then the final expression, the induced EMF in a conductor, the EMF is produced in a conductor, the E is equal to B into L into V, B into L into V. If the conductor is moved at an angle theta, if the conductor is moved at an angle theta to the magnetic field, then the velocity at which the conductor is moved, the velocity at which the conductor is moved across the field is V into sin theta, and the induced EMF is BLV sin theta, BLV sin theta. Then the EMF E is equal to BLV sin theta, where sin theta is nothing but the sine angle between the conductor and magnetic lines of force or magnetic flux in the magnetic field, So this is called as the dynamically induced EMF. This is the expression for dynamically induced EMF. If the conductor are the taken the some angle, so that is the sine angle between the conductor, center of the conductor to and magnetic lines of force, that is the angle between the center of the conductor to magnetic lines of force. So here if the conductor move at an angle theta to magnetic field, okay, now 1 second we have to read this sentence. If the conductor are move at an angle theta to magnetic field, then the velocity at which the conductor is move across the field is V sin theta, and the EMF is BLV sin theta, where the EMF is equal to BLV sin theta, in volts. So the EMF is nothing but it is the EMF electromotive force. So it is called as it is indicated with the units of EMF is the volts. So where B is the magnetic flux density, L is the length of the conductor, the V is the voltage, and sin theta is nothing but angle between the conductor and magnetic field, Next, statically induced EMF. Statically induced EMF. The statically induced EMF. What is the statically induced EMF? When the conductor is stationary and field is changing, due to the change current in the electromagnet. When the conductor is stationary and the field is changed due to the changing the current in the field is changing due to the current change in the electromagnets. The EMF is induced in the conductor is called as the statically induced EMF. the EMF is induced in the conductor is called as statically induced EMF. The statically induced EMF is further divided into two types. Here, what are the statically induced EMF? Statically induced EMF is nothing but here the conductor is the stationary, the field is the rotating. Then the EMF is produced. The EMF is produced in that conductor. The EMF is produced. EMF are induced in that conductor. Here the induced EMF and EMF is produced in a conductor. Either conductor are the moving, or the field is the conductor is stationary, field is the moving, and field is the stationary, conductor is the moving. Okay now. So here in these causes the flux will be changes. The induced EMF produced in that conductor. Okay now. So here the statically induced EMF is nothing but when a conductor is stationary, the field is changing due to the changing current in the electromagnet, Then the EMF is induced in that conductor. The conductor is called as statically induced EMF. So it is the two types is there. First one nothing but self-induced EMF, and second one is mutual induced EMF. Self-induced EMF and mutual induced EMF. So what is the self-induced EMF? What is the mutual induced EMF? We have to discuss about self-induced EMF and mutual induced EMF. So this is the figure. For self-induced EMF. So here this is the coil, this is the conductors, this is the EMF induced. So these are the number of turns. Okay now, and batteries are connected. The batteries are connected to this coil. So here current will be flowing through this coil. You have to observe the direction of mark with the direction. Then here if the current in a coil of n turns, okay now, number of turns is there. So here the current will be flowing. The flux will be linkage of this coil. Will be also changes. This will be state of is called as self-induced EMF. That means, okay now, if conductor is carry the current, the magnetic field is produced around the conductor. That means the EMF is causes, the flux will be changes, the EMF is produced in that conductor. So here if current in a coil of n turns, here number of turns is there in that coil. So the current is flowing in that coil n turns, changes the flux linkages of the coil, changes the flux linkages of the coil. So here the flux linkages of coil also changes. So this will be set up a self-induced EMF. So here the induced EMF E is equal to N into d pi by dt. So here the N is the number of conductor and d pi is the change in flux and dt is the change in time period. So the flux is due to the current in the coil. So the flux linkages will be proportional to the changing of current. That means the flux linkages, producing the flux linkages will be directly proportional to the current. If the current will be increases in the conductor, the flux will be increases. Current will be changes, the flux also changes. In the conductor. So therefore the E is directly proportional to the change in current with respect to time. So the E is equal to constant into some proportional constant into change in current to change in time period. change in time period. So the E equal to L into di by dt, where di is equal to change in current, where di equal to change in current with respect to change in time. So where constant L is called as the self-inductance, where L is called as the self-inductance and inductance of the coil, So do you know that types of induced EMF in this device? So this is the primary winding, this is the secondary. If the source is connected to the winding, is called as primary. If the source is connected to the winding, is called as primary. If the load is connected to the secondary, which winding are connected with the load, that is called as the secondary. The winding which is connected with the load, that is called as the secondary. The winding which is connected with the source is called as the primary. So this is called as the statically induced EMF. Do you know the type of the induced EMF in this device? So this is the AC generator and DC generators. Okay na. In the DC generators, the conductors are the moving and field is the stationary, and in AC generators the conductor is the stationary, the field is the moving. So this is called as the AC generator and the DC generators. Next, mutual induced EMF. The induced in a coil due to the current change in the neighbor coil is called as mutually induced EMF. The EMF induced in a coil or conductor. Due to the current change in the neighbor coil. So let us consider. You have to observe here. Two figure is there. You have to observe the two figure here. So this is the battery. These are the battery. Okay, now these are the coil. So here one coil you have to connect it with the battery. The other coil is not connected, but here he is connected here. So let us this figure. Consider these two coil placed adjacent to each other. Two coil are placed adjacent to each other. So the mutual flux. If the current flow in coil 1, the flux will be set up. If the current will be flowing through the first coil, so the current will be set up. So here we have to observe. Here the battery is connected in series with the resistance, and switch also connected in the series. So here the current will be flowing. When the switch will be closing, the current will be flowing. If the current will be flowing, the flux will be set up. In a coil. So this set up in it, and the part of flux will be linking with the other coil. So this common flux will be linking the both coil. Common flux will be linking in both coil. Flux will be linking it. So flux will be linking in both coil. That is the moving in from first coil to second coil to first coil to second coil. The flux will be linking in the both coil. Then the EMF is causes in second coil. Then it is called as the mutual induced EMF. That means the induced EMF in a coil produced due to the current change in the first coil, or neighbor coil. So this is called as the mutually induced EMF. How to produce mutual induced EMF? Here the current change in the coil, the flux will be changing. This common flux will be produced in the both coil. Common flux will be moving in the both coil. then the mutual induced EMF is produced. The mutual induced EMF is produced. So this is about the mutually induced EMF. So that means the induced EMF in a coil, the induced EMF in a coil, the induced EMF in a coil, the induced EMF in a coil due to the change, due to the current change in the neighbor coil is called as mutual induced EMF. Simple definition, simple definition. The EMF induced in a coil, the EMF induced in a coil due to current change in the neighbor coil, due to current change in the neighbor coil is called as mutually induced EMF, is called as mutually induced EMF. So if I1 is the current change in mutual flux linkages, the EMF is induced in the second coil. Here the coil 1, coil 2 is there. Here if I1 is the current change in the, I1 is current flowing through the first coil, I1 current flowing in the first coil, the mutual flux will be changing from the coil 1 to coil 2. Then EMF is induced in the coil 2. The EMF is induced in the coil 2. The EMF in a coil 2, here E2 is proportional to the change in the current in first coil. So here the change in I1, change in current I1 with respect to the time. So the E2 is equal to constant proportionality M into di1 by dt, di1 by dt. So where M is the mutual inductance, M is the mutual inductance of the coil, mutual inductance of the coil. So we have to observe this figure, mutual induced EMF, mutual induced EMF. So in this period we have to learn about the type of induced EMF. First type is nothing but dynamically induced EMF. Second type is nothing but statically induced EMF. What is the dynamically induced EMF? What is the dynamically induced EMF? Here the conductors are the moving, field is the stationary. For the DC generators, for AC generators, the conductor is the stationary, the field is the moving. That is called the dynamically induced EMF. Statically induced EMF. What is the statically induced EMF? What is the statically induced EMF? The statically induced EMF. Here the induced EMF. Here the coil, that in a coil the change in the flux due to the current flowing through the conductor is called as a statically induced EMF. Statically induced EMF. The statically induced EMF two types is there. That means here self-induced EMF, mutual induced EMF. Self-induced EMF, mutual induced EMF. Here conductor is the stationary, the conductor is the stationary, the current is the changes in the conductor, then the induced EMF is produced. So it is the two types is there, that is the self-induced EMF and mutual induced EMF. Self-inductance, self-induced EMF and mutual induced EMF. So next some quiz question is there. The EMF is induced in a coil dash statically induced EMF. Statically induced EMF. So the example of statically induced EMF is nothing but transformer. Option A is DC generators, option B is transformer, option C is DC motor, option D is none of these. Option B is the correct answer, that is the transformer. So here next question, the EMF is induced, EMF is induced in a dash is the dynamically induced EMF, dynamically induced EMF. DC generator, option A is equal to alternator, option B is transformer, option C is DC generator, option D is none of the above. Option C, DC generator is called the answer, correct answer. The unit of magnetomotive force, ampere turn. Magnetomotive force is nothing but, okay, now option C is correct answer, that is the ampere turns, ampere turns. Next quiz question. The EMF is induced by the conductor is also is known as self-induced EMF. Option A is correct answer. the EMF is induced by the conductor is also known as self-induced EMF. Option A is the correct answer. Next, transformer works on the principle of option A is Lenz's law, option B is electromagnetic induction, option C is Fleming left-hand rule, option D is none. So option B is called as the correct answer. That is the based on the principle of electromagnetic induction. Based on the principle of electromagnetic induction. Some example question is a frequently asked question. What are the types of induced EMF? What are the types of induced EMF? Dynamically induced EMF and statically induced EMF. Statically induced EMF remain two types is there. The self-induced EMF and mutual induced EMF. And derive an expression for dynamically induced EMF. That is the E is equal to BLV sin theta. BLV sin theta. Let's derive an expression for the self-induced EMF. Derive an expression for self-induced EMF. That is the E equal to L into di by dt. E equal to di by dt. So this is the frequently asked question. You have to keep in your mind today class. Okay, thank you. So if any doubt is there, just you have to read a reference book. Then you would be able to understand. Okay, thank you.